As a result of this, they will be charged twice for the same order. Now, this is a very real problem in distributed systems. Networks are unreliable. We have already discussed that in our previous video of 8 assumptions that can break our systems. If you are interested in learning about all those assumptions, go ahead and check it out from the top right corner of your screen. Now, moving back to today's topic. So, in a microservice architecture, during the interaction of different components in a system, a request can time out or response can get lost and the client can retry the same calls multiple times. Now, if your API isn't designed to handle the duplicate request gracefully, these retries will cause issues such as duplicate transactions or charging the customer twice, and also will result in inconsistent states in your database. So, how do we prevent this from happening? Now, this is where idempotency comes into play. In simple terms, idempotency means that no matter how many times you perform an operation, the end result should be same. The system should treat repeated identical requests as if they were made only once. In an idempotent API, repeating the same request will not change the system's state beyond its first execution. That means whatever was changed in the first execution of that request, that will remain as it is for all the upcoming repeated requests. This principle becomes extremely important in the systems like payment gateways, shopping carts, ticket booking systems, or anywhere where duplicate processing can lead to financial or logical errors. Now, without idempotency, retried request could lead to double charges, two tickets getting booked for the same seat, or duplicate entries being created in your database. Now, let us take a very simple example. You have this payments API that charges the customer for an order. The client sends a post request to this payments API with this particular payload. Now imagine the network drops right after the server processes the payment, but before the client receives success response. Now the user will think maybe the transaction failed and they try to retry the same request. And guess what? The server processes another 100 rupees transaction because it doesn't know this request is a duplicate, and in this way the customer is charged twice. That is really bad and is totally unacceptable in payment systems. So, what could be the solution? The most common solution is to use an idempotency key, which is a unique identifier the client sends with every request. Every time the client initiates a payment, it generates a unique key for that specific operation. It will be like XYZ123 in this particular payload. So when the server receives the request, it checks whether it has already processed the request with that particular idempotency key or not. If it's the first time, then it executes the payment and stores the result along with the key in a database or a cache. But if the same key comes again due to a retry or duplicate request, the server doesn't perform the payment deduction again. It simply returns the same response that it gave for the first time. Because before executing the payment, it will check if that idempotency key is present in the cache. Then it will fetch the response saved corresponding to that particular key and return to the client. In this way, even if the user clicks pay now 5 times, only one actual payment will happen. The others are safely ignored. This approach ensures exactly one's behavior at the API level. Now, idempotency helps our API act predictably, which makes our system more resilient and trustworthy. Because when users know their actions won't be executed multiple times accidentally, it builds confidence, and that is what reliable systems are built upon. So that's all about idempotency and how we can implement it with a very simple approach of idempotency key. If you think this video was helpful, don't forget to like, share and subscribe. Also press the bell icon so that you won't miss any new update. I'll see you in the next video. Till then, let's keep learning.